Hello everyone. In continuation with the series of exploratory data analysis, today we are going to talk about another characteristics of frequency distribution, that is dispersion. Literal meaning of dispersion is distribute or spread over a wide range. In statistics, it represents how data points are distributed or scattered over a wide range of values or around central value. Hence, it measures the extent of variation in a data set. Here we have two data sets, each with sample size of 10. By simply examining both the data sets, we can easily make out that dataset 2 is more dispersed as compared to dataset 1, because in dataset 1 minimum value is 20 and maximum is 25. So that means all 10 values are in between these 2 points, 20 and 25. While in the second dataset the minimum value is 0 and maximum is 100. So here the 10 data points are distributed in between 0 and 100, the wider range. So that is why dataset 2 have more dispersion as compared to dataset 1. Now let's understand this with the help of one more example. Here again we have two data sets. Dataset 1 have 5 observations and dataset 2 have only 3 observations. Both datasets have same mean or median value, that is 3. But do you think data is equally spread in both the datasets? So that means if we are talking about variation in dataset 1 and dataset 2, is it same? Answer to this question is obviously no. In dataset 1, observations are 1 unit apart, right? The difference between 1 and 2 is 1. Difference between 2 and 3 is 1, and so on. While in dataset 2, this distance is 2 units. So the difference between 1 and 3 is 2. The difference between 3 and 5 is 2. So that means both series have different pattern of dispersion. If we try to understand concept of dispersion with the help of visualization methods, figure 1 here can help us. In figure 1, we have frequency distribution of 3 data sets represented by 3 different colors, that are blue, red and green. In a distribution represented by blue color, that is this one, most of the values are clustered around central value. Distribution represents by red color indicates bell-shaped curve that is symmetric around central value, and data points in red color distribution are more scattered as compared to blue color distribution. Similarly, distribution represented by green color is much flat at its peak and values are much scattered. So in summary, we can get an idea of dispersion or scatterness by frequency distributions by looking at its peak and tails. Peak and tails. How? If peak is sharp, then it indicates values are clustered around center, and if peak is broad, or what we can say is if peak is more flat, then values in a data set are not very close to central value, like here in green color distribution. Here the peak is not very sharp, it's flat. So that means values are distant apart from each other, while in blue color values are very close to the central value. Similarly, lesser the distance between both the tails of the distribution, lesser is the dispersion. So here in blue color there is very less difference between the smallest value and the largest value. So that means again the same interpretation, values are close to the central value. So this distribution is less dispersed as compared to green color graph. Here the difference between the smallest and the largest values is quite high. So the values are more scattered. So in this distribution, values are more dispersed as compared to blue color graph. So to summarize, dispersion is very useful for understanding data, as along with central tendency, it gives more insight about our data. It helps in understanding the distribution of data, and it forms basis for statistical theory. How it forms basis for statistical theory? Because suppose if there is no variation in the data set, like suppose age of each student in the class of PG students is 23 years, then there is no need of sampling. We are sure that average age of PG students is 23 years. In fact, each PG student is 23-year-old. So if there is no variation or dispersion in the data set, we are dealing with certainty. So there is no need of doing statistics. Also, because variability in data points is inherent in nature, statistical techniques help us to explore patterns and predict outcomes, and becomes one of the initial step of exploratory data analysis. So dispersion and its measures is very important for understanding our data. I hope now concept and importance of dispersion is clear to all of you. Next question is how to measure it. So just like we have discussed measures of central tendency in earlier videos, now it's time to understand measures of dispersion. Dispersion can be measured in two ways, that is absolute and relative. Absolute measures are directly calculated from data, expresses the average variations in terms of the deviation around some values, usually central values. Absolute measures, which expresses the dispersion in terms of distance between some data points. Such kind of absolute measures are also known as distance measures, like range, interquartile range. Okay, so here range, quartile deviation and interquartile deviation are distance measures. Another way to compute absolute measure of dispersion is take average of deviations of each data point from some central value. For example, mean deviation, variance and standard deviation are example of another way of calculating dispersion. Okay. On the other hand, relative measures of dispersion are unitless. So this is why it is useful, because relative measures are unitless. So whenever we want to compare variation of two different series, we should use relative measures of dispersion instead of absolute measures. For example, we want to compare variation in height and weight. Okay, so we have two variables, height, say in centimeters, and weight in kgs. And we want to compare variation in height and weight. So in this case, we should use relative measure, not absolute measure. Why? Because if we are using absolute measure, then variation, whatever measure we use for measuring the variation in height and variation in weight, the unit of variation will be centimeter for height and kg for weight. Okay, or in terms of centimeter or in terms of kg. But if we are using relative measures, then what will happen? we will get absolute numbers. So that means they are unitless. So in this case, it is easy to compare the variation between two series. So basically, absolute measures are used to explore variation within particular characteristic or variable. Like here, if I want to know the variation within height variable, then we should use absolute measure. But if I want to know variation between height and weight, that means intervariable dispersion, then we should use relative measure of dispersions. Okay. We will discuss in detail for each measure of dispersion in upcoming videos. So don't worry, it's just a brief, and we will definitely cover all the measures in detail in subsequent videos. Till now, I request all of you to please refresh the concept of data types in central tendency. You can find the link of these topics in description box too. This will help us to understand dispersion and its measures. So till yet, if you have any queries, please feel free to drop an email to me. I would love to answer all your queries. Keep watching, keep learning. See you next week.